Hello everyone, welcome to the Mammothon tutorials. I hope you're all excited to get started. We're going to start off with a short introduction. So first of all, I wanted to introduce myself. I'm Rebecca, I'm the Program Manager for the Mammothon from Encode Club. And I'll be in contact with you throughout the program, and if you have any questions at all, then I'm the person to ask. So just send me a message on Discord or by email, and I'll try my best to help you out in any way that I can. So at Encode Club, we're an education community. We help you learn, build, and forge your careers in emerging technology. We do this through educational events like hackathons, public education series, boot camps, and accelerators. And we hope those of you who are new and joining us from the Mammothon will stick around in our community as you build and grow, because we're really excited to be part of your journey. So let's talk about the Mammothon. It's a really simple process. You have 28 days to build and ship your projects and be in with a chance of winning part of the $250,000 prize pool. So that is huge. The prize pool is going to be split evenly between the top 10 teams across all idea tracks. Now, this is where the Mammothon is a special event. In the Mammothon, you don't have to come up with your own project concept. There are Celestia Ecosystem partners who have shared ideas on what they want to see built on their tech stack. So they've given you all the resources that you need to succeed. You can build unstoppable apps, you can craft on-chain worlds, and you can upgrade the internet. The last thing to mention about the Mammothon before we move on to the tutorials is that in order to participate, you must be in a team of 3 to 5 devs. If you've not already, please read your emails for information on how to build up your team or how to register the other team members in your team to make sure that you qualify to compete in the Mammothon. When we launch, we'll have over 30 ideas, which means a few more are going to be announced very soon, so keep an eye out for that. And each one comes with a matching tutorial. This is really important. We want to make sure that you have everything you need to start the Mammothon so that you succeed. In these workshops, you're going to get all the essential technical skills that you need, and you're going to have the opportunity to ask questions and clarify requirements with each of the idea partners. Okay, so that is everything from me. Let's jump right in.
So today I am going to talk to you guys about Chopin Framework. And by the way, there's been a debate whether this should be called Chopin, which is like the French inspired. There's a famous composer named Chopin or Chopin. Or maybe some people like saying Chopin, the Chopin framework. So let me know in the chat what you guys like. But anyway, I want to tell you first a little bit about myself. So I'm the creator of Chopin Framework, and I'm the founder of a company called Modular Cloud. And the reason why I want to tell you a little bit about my background is because I'm also a builder in crypto, and I think that my story can help people maybe get some inspiration for what they should do for their project and how they can take that and turn it into a business. So essentially, several years ago, I came across Celestia. I read the original white paper that Mustafa had written, and it was extremely inspiring. I saw that Celestia was going to be a very important piece of the puzzle for scaling blockchains and also for unlocking innovation because it would allow all these different applications to customize the execution environment and do all of these awesome things. So I got really excited about Celestia, and I at the time was working as an engineer at just another company, not in crypto, and I wanted to work for Celestia. So I DM'd Nick White on Twitter. And I asked basically if I could work at Celestia. And since I didn't really have the relevant experience, I was an engineer, but I had never built a protocol before. And they were, in the early stages of developing Celestia at the time. I didn't really have the resume to impress them. And so one thing but they did give me an opportunity. They said, you should build a project and show us what you can do, and we can use that as a way of assessing your skills since you don't have the relevant experience that we're looking for. And so I took up that challenge, and I decided I would build a project in the early ecosystem for Celestia. And what I wanted to build initially was a chat application that put the messages on Celestia. And this was before they launched mainnet. This was before they launched even any test nets. At the time, they just had this dev net that was not documented. It was for development purposes only, and it was not even fully functional, but it did have the base functionality. And I wanted to build a chat application that would run on top of this Celestia DevNet, and my goal was, to make a project that would impress them. So I dug into the code. I spent a lot of time reading it, trying to get familiar with what was going on, and it was very hard because there wasn't documentation, and I wasn't familiar with Go or the Cosmos SDK or anything like that. But what I learned in that experience is sometimes when you're just when your back is against the wall, you're focused, you're trying, and you're struggling, you can just keep pushing through. And if you just keep, like, all of this code is open source, and if you just keep working on it, at a time that you get stuck and you just keep pushing through, eventually you can understand how these types of systems work. So I just kept reading the source code. I kept diving in, trying a bunch of things. And eventually what I did was I built an indexer that would power my chat application. And this indexer went and got the data off of Celestia, and it put it inside of a MongoDB database and created an API so that anyone could query it. So when I showed this to the Celestia team, they actually really liked this project. And one of the things that they said is that I should consider starting a company around this project. And they were nice enough to introduce me to a bunch of investors. And I realized that there was a need in the Celestia ecosystem for some sort of infrastructure providing company. So I ended up, even though this was not my initial plan, I ended up figuring out how I could build a business around this and pitching it to investors. And I ultimately successfully raised a pre-seed round. I raised 1.7 million. And I've been working on modular cloud ever since. And the reason why I founded modular cloud was because I knew that Celestia was going to be a paradigm shift in the blockchain space. It was basically changing the architecture of how blockchains were built. And there's just a lot of different assumptions that would need to be made when we were moving to Celestia from something like Ethereum. Like, for example, instead of a world where there's just one chain, there's now going to be a world where there's thousands of chains, and the scale is very different. So that was the thesis that I had when I created modular cloud. And I'm not going to go into the reason exactly why I shifted my focus from the original vision of building data retrieval APIs and a block explorer to Chopin Framework, but essentially the short version of that is that when you want to build very general infrastructure for blockchain applications and you want it to be customizable for the needs of each application, what you end up realizing is instead of building you end up basically needing to build tools that are so general that they don't actually need to be blockchain specific tools. So, like, for example, let's say you want to retrieve data from Ethereum. You would potentially build an API that works really well with the way that Ethereum is constructed. And so you can call this an Ethereum API. But what if you have thousands of different chains? Some of them are application specific chains, and each of them have different architectures and work differently. When you have such a large audience, essentially the abstraction breaks down. And what you end up doing is you end up recreating the tools that people use in the first place to retrieve data in the cloud. So you just end up making another web framework, essentially. And what I realized while going in this journey and trying to build infrastructure for this new world of modular blockchains, I realized that what developers need is that developers need to build things with the tools that are already established and already proven in tech. Like, sometimes we need some blockchain specific framework or library. It is sometimes necessary, but a lot of the times the best tools for the job are tools that have already been established. For example, let's say you're trying to build a web application. one of the best ways to do this is to use React and Next.js. And it turns out that it's actually not necessary to use blockchain-specific tools in order to bring blockchain security and blockchain interoperability to Next.js and other web applications. So that's basically how Chopin was created. So Chopin is essentially applying the roll-up architecture to web apps. So this is how you should think of it working. So essentially, someone comes in a browser, and normally the browser connects directly to the server. But what the Chopin architecture does is it puts what I call a verifiable reverse proxy in between the browser and the server. And what this does is it serializes all the requests going between the browser and the server and puts them on the blockchain. And in this way, all the requests can then be replayed so that you can deterministically rebuild all the state on the server. Just think of it as an interceptor that just goes between the user's device and the backend. And by passing all the traffic through this proxy, it makes the application verifiable and interoperable with blockchains. And essentially what we've been able to do is craft an experience that's just like Web 2, but it has Web 3 security. So for example, I'm going to go over here. This is the website for Chopin Framework, chopin.sh. I just said hi. Now I'm going to say bye. And let me refresh this so you can see this tracker. So as you see, it optimistically updated the UI, and now it is signing this message with an embedded wallet, and it is now sending it to the DA layer. So right here, what you're seeing right now is a decentralized application with roll-up security. What I just did was I interacted with a web app. It seamlessly created an embedded wallet in the browser, and it took the HTTP request that was made from the browser, it signed it, and it put that onto Celestia. It's still waiting for the DA layer confirmation, but that's what is going to happen. And so, as you can see, I didn't have to configure a wallet or do anything or download anything, download any extensions or applications in order to do this. This actually used, someone said GM to you as well. This is a Web 2 UX, and but everything is secured cryptographically under the hood. So you might ask, okay, that's a very nice experience, but it must be very hard to build. How did you build such a slick experience? You must have had to integrate an embedded wallet, do all of this stuff, have all of these layers of these data retrieval APIs, bring in data from the blockchain, and have some sort of wallet connector and construct a transaction and broadcast it. And that's actually not true. You don't have to do any of that. So I'm going to just go back on the slideshow. So all that you have to do, I think this is, all that you have to do is out of order slides, but is 3 steps. One is you just install the package. We have a Chopin Framework Next.js specific package that is optimized to work with Next.js. And you can install the middleware, and you put the provider in the layout. For those that are familiar with Next.js, this will probably make a lot of sense. You can look at the docs to see these instructions. It's very straightforward. And what happens is by doing this, we're able to inject the middleware onto the server side and communicate with a light node that connects to Celestia, and then passes all of the requests through between the browser and the server. And from a developer's perspective, that's actually all that you really need to think about, with a few caveats, which I'm going to cover later. And so really, as a developer, you have the opportunity in this hackathon to build the kind of web app that you want to build. I'm assuming that most people here that are looking to build applications are already proficient in Next.js and React, because that's just like, in order to build a UI, you basically need to know how to build a web app. Like, if you think about it, usually it's like every blockchain developer that's building a blockchain app is also a web developer. So I'm assuming that most people who are interested in building apps here already know how to build web applications. So adding Chopin in that stack is going to be really easy, and it's going to allow you to focus on just building the app that people want to use, as opposed to trying to get the blockchain component to work. All of that stuff is abstracted and handled by the Chopin framework itself. So there's lots of resources for this. There's the docs, as I mentioned, and then there's also over 1 hour tutorial that I did. If you follow Chopin Framework on X, you can watch this stream I did with Josh Stein, and I not only go way deeper into the Chopin architecture, I talk about the big picture, why this is important, why I believe that the internet is going to be transformed when we use Celestia to secure the traffic coming into a very large number of apps, and how we're going to basically upgrade the internet and make the internet verifiable. This is the next paradigm for creating a verifiable internet. So now this is a very nice developer experience, but some of you also might be thinking, I don't prefer Next.js. Well, I'm happy to announce today that this just got even easier. So now we have a command line tool that will handle all this for you, and you no longer need infrastructure specific packages. So for example, so all you have to do is, if you have Node.js installed and npm installed, you just have to say npx, which just means that you're downloading and executing this package, and the package is called chopd. And so now with chopd, what you do is you just say npx chopd, you run that alongside your web framework, and it will spin up a local reverse proxy and do all of the things that Chopin needs to do so that you can get started developing locally. You can still do it this old way, but now we have an even better way to do this. And so just really quickly, this is just an overview of what chopd is doing. This should say chopd architecture, not Chopin architecture. Essentially, chopd is spinning up a reverse proxy on your machine. So let's say that Next.js is running on port 3000, chopd will be running on port 4000. The browser instead, so when you go to your browser, instead of connecting to the server on localhost 3000, what you're going to want to do is you're going to want to connect on localhost 4000. And chopd will make this experience seem as if you're connecting to the original port. So you can load chopd, you go to localhost 4000, and then it's going to serve you your Next.js, Remix, whatever sort of backend you want to use. And there are these simple HTTP hooks that can do things that are very useful. For example, if you want to generate a wallet, you can go to get/_Chopin/login. And if you want to, as a developer, see the logs of all the requests that have come into the server, you can just go to /logs. So this gives you extra developer tools to inspect the series of requests that you made and understand why things are behaving the way that they are. Another thing that is handled by this reverse proxy is the oracle. And we'll get into that a little bit more later. But essentially, whenever you need to, let's say, make a fetch request to a web URL, you'll use the oracle module, and that oracle module is going to fetch the data on the server and then send it back to the reverse proxy so that that can be verified and put on chain. So for this hackathon, we're going to have two projects. The first one is a Twitter clone, and if you go and you check out this URL, I already have a repo up for this one. And so if you just go over here, I actually made this 100% with AI. And I want to, at another time, I want to go through and show people how I did this, because I think it's super powerful. But this was basically, if you go here, you can go and, you know, I already have my name set as hello, but you can say hi. You know, you guys can go and play with this. And so the way that I built this, just because I want to like share this type of knowledge and help people build apps quickly and painlessly, I generated this UI using V0. It's v0.dev. It's a service that's provided by Vercel. There is a free tier, and it creates very high quality front ends based on a chat interface similar to ChatGPT. I highly recommend this for anyone who's building a web app and is not a designer and just wants to get something going. I just described what I wanted very briefly. I said I want a simple Twitter clone. I want a box where you can write your tweet, and I just described all of these UI elements. So for example, I can go and filter by clicking here. It was able to implement all of this just with AI, and it was super easy. So I highly recommend you guys check out v0.dev. It's a really great tool. But the problem with v0.dev is it doesn't have any API or backend functionality. And so what I then did was I took that code from v0, I put it into Cursor, and I used Cursor's agent to build out to convert the front end React code to a backend API. And then I plugged in Chopin Framework and it worked. And so that's basically the flow that I recommend. But since it took me a few hours to build this, it was quite easy. But that's a little bit too long for this presentation. So I'm gonna have separate videos that I'm gonna release where I fully go end to end building both this simple Twitter clone and the image flip clone. And you can read the details of these on the Hackathon website if you want to know more about what these are. But this is just kind of a proof of concept of something that can be built super easily. And what I essentially recommend is I recommend for this hackathon, and of course, you don't have to follow my advice, but I recommend, given the power of iteration that AI gives us, the fact that I could build multiple apps in one day, I would recommend just trying a lot of different things and building. Don't worry too much about the design, worry about functionality, worry about finding an app that people want to build. And if there's a web app for it, Chopin Framework can power it. So since Chopin Framework is essentially just a thin wrapper on top of Next.js or other web frameworks, you are free to spend most of your time focusing on finding product market fit. And if you do, I think you're going to have a lot of success. You'll both have I don't know exactly the criteria for how things are judged here, but I would assume if you create something where you get users and prove that people want to use it and that you focus on that kind of a thing, that you're going to have a lot higher of a chance of winning a prize in the hackathon. And also, I think there's a lot of investors that are watching and other teams that provide grants and potential collaborators, co-founders. And all of these people will be they're going to be much more interested in talking to you and working with you if you focus on finding things that people want to use. So I hope that these AI tools, a lot of which are free, give you everything you need to build a compelling application. And Chopin Framework really doesn't add many requirements, and it doesn't really add any extra work or extra knowledge on top of just using AI. So I think this is going to be just a really great way for people to build things, and that's the route that I recommend going. So now there are a few things that you do need to keep in mind when you're using Chopin Framework. And so it's not exactly the same as Web 2. There are a few constraints. And one of which I didn't write here, is that you should know that there is a performance bottleneck that is introduced by using Chopin Framework over something like just regular Next.js. And the reason for that is because at the moment, each request needs to be executed sequentially. There's not any sort of multi-threading that goes on. And so that does slow things down. In order to avoid data races and stuff, we have to basically throttle the throughput through Chopin Framework applications. But honestly, I've never noticed that being an issue. If you have a lot of users, it could at some point cause an issue. But what I will say is that is a 100% fixable optimization that we just need to prioritize at some point. And so that's a solvable problem. And the second thing is, if you have a lot of users, that's a good problem to have. And it's basically, blockchains are slow, so putting a web app on the blockchain is also slow. But just like there's a lot of next-gen blockchains that are highly optimized, Chopin Framework can also become highly optimized. So I just want to get that out of the way, but let me let you guys know about the some things that you should also keep in mind when you're developing these apps. So first of all, everything is public. So all the requests going to your app, the post request, put request, delete request, whatever you're doing, whenever you're modifying the state of your app and adding something to the database and all of that, that's all public. It's a public log of requests going to your app. It's put on Celestia. So you don't make an on-chain diary or something like that, something where it's sensitive information. Don't make private messages on-chain unless you're doing client-side end-to-end encryption, which you can do. We don't do that. We don't support that as a feature ourselves, but you can, you would never trust, you would always implement that on the front end anyway if you wanted it to be secure. So you could do end-to-end encryption, but just know that still the metadata of that will be on chain. And it's just something to keep in mind. This is for public applications, like public blockchains, public ledgers. So if this is good for things like social networks, it's not good for things like, in a sense, it can be good for something like cloud storage or private messages, as long as you are end-to-end encrypting them, which you would have to implement yourself. It could be good for that. There's benefits to putting that type of data on Celestia, because Celestia will guarantee that you'll be able to download it within 30 days. There are benefits to doing that, but typically, these are for public open applications. So I really like the idea of games and social networks and things like that. Like the type of things that we have as projects for this track are things that you should consider making. Another thing just to keep in mind is, if you don't put any API keys or anything in the code, because that will be, the code is also public. When people verify the code, they're going to have to run it. So also, again, you're going to have to make your application open source. If you have a really great web app idea and you don't want to make it open source, it's not going to be very well suited to be a verifiable protocol, because you need to make the code open source. And so essentially, you just have to keep in mind that the full execution of this application is open. All the inputs are logged. All the requests you make to and from services are also logged, and the source code is public. So just keep that in mind. You could obfuscate the code if you want to figure out how to do that, and then maybe people wouldn't be able to copy you as easily. That's an option, but basically everything is public. That's the first thing to keep in mind. Now, the second thing to keep in mind is that you don't want to send username and password to the server. That would be bad, because everything is public. So now everyone will know your password. It's not going to work. It literally won't work. So what do you do instead? Well, we have the authentication built into the Chopin Framework packages. So you can use the get address method inside of Next.js. And when you just call get address, it gets the address of the user. And if you're on the client side, you can use the use address React hook, and that will just give you the address of the user. This is something that's completely automated, so it's quite easy to do. This is actually easier than implementing regular authentication. Right now, we only support embedded wallets, but soon we will also have support for third-party wallets like MetaMask and stuff like that. So people will be able to bring whatever wallet they want to use for this application. But for now, we only have embedded wallets. And if you're not using Next and you're not using React, you can just get the address from the X address header inside of the request. And this will work in any web framework. Just get the X address header. And the reason why there's an X address header present that you're able to get the address from is because that's what one of the functions of the verifiable reverse proxy that sits in front of your backend. It intercepts the traffic, it gets the signature of that is attached to the HTTP request, and it extracts the address from that and adds it to the header. So then when you're developing the app on the server side, you don't need to think about doing any of that kind of stuff. It's already added as a header, and it's verified by the proxy that's sitting in front of your backend. So it makes it super easy. And also, to log in, you can generate a wallet by going to this sub URL, which right now is only supported by Chopd, not by the server. Not by the Next.js package. If you're using the Next.js package, it will automatically create a wallet for each user when they first visit your website. But what I will say is we're going to update that so that it also has the login mechanism. Now, the final thing to keep in mind is that you want to make sure that everything is deterministic in your application. And what this means is that you don't want to have any sort of route or function that executes in your web application that gets a different result if you do it a second time. It should always get the same result when it's run with the same input. And so the way that we handle this is we have an Oracle module, and this Oracle module will essentially cache the things that are non-deterministic, and it will attach it to the request when it's as what we call context, when it's added to the blockchain. So for example, let's say you make a request and you fetch weather data as part of that request. Now, if you do that at another time, the weather will be different. So it's going to be, you can't trust that that's always going to give you the same result. So what the Oracle module will do is it will fetch that weather data at the initial time that the transaction executed, and then it will store what result that it got at that time, and it'll put that result on chain so that when the transaction is replayed, instead of doing the fetch action again, it's just going to take the cached result and plug it in as if it had fetched. And so just like here are a couple examples of things that you could do in the backend that could be non-deterministic. You could use fetch. You could do date.now, because the moment that you're in changes every second. You could say new date. It's similar to doing date.now. It's just a date object. You could say math.random, because every time you do that, you'll get something different. It's random. And you could get a random UUID. Again, that's going to be random every time. So all of these things are things that can be solved by the Oracle. The Oracle has a timestamp function. The Oracle has a random number generator, and the Oracle has a general what's called a notarized method, which will just take any sort of non-deterministic input and it will sign it and say that this is what this is what we got. And so you have to trust the sequencer for this, but it is a way that you can even include things that don't have better forms of verification. So one thing that we are going to be launching very soon is a third-party notary service for API requests. So Fetch will have slightly more cryptographic guarantees than if you just trusted the sequencer. You can now trust the sequencer and modular cloud because we will notarize it. And a bit later, we are going to implement zk-TLS, so you have even more guarantees that fetch request was done properly. And we're working on securing this Oracle module. So this is something that's currently under development. But what this enables you to do is basically you can do all the things that you would normally do in a Web 2 backend, and with just a slight modification, you are able to bring that over into to become a verifiable Web 2 application. So one other thing I wanted to mention is you can use any sort of database that you want. For example, in all of the examples that I've done, I've used Postgres, and it works as long as it also is deterministic. So one thing that you don't want to do is you don't want to have some sort of current timestamp generated by the database, because then when you go in and you replay the transactions, it's going to insert them into the database and it's going to generate another timestamp. And that'll be different from the one before. So what you should do, instead of having the database set the timestamp, you should set the timestamp in your TypeScript or JavaScript code and then pass that into the database when you're doing an insertion or a modification. But one thing that is totally fine to do is if you have some sort of auto increment key, that's totally fine because it's going to auto increment for each. So let's say you're adding one message, then you're adding another message to the database. That's going to happen in the same order when you're replaying it, and then they're going to have the same auto incremented key. So that's it. That's the only types of things that you need to keep in mind. It's pretty simple. You can just build your app the way that you want to build it using any web framework, and with just by simply running chopd, and if you need the Oracle module, installing the package Chopin Framework, you'll be able to use that Oracle module in conjunction with chopd, and you're going to be able to make, it's not just going to be a Next.js app, it's going to be a verifiable Next.js app. So what's next? We're going to have weekly tutorials dropping for the remainder of the hackathon, and anything in this introductory presentation that was not abundantly clear will be expanded upon. So we're going to, for example, walk through in detail making the Twitter clone and the image flip clone. And of course, you guys can then take that and run with it in the hackathon and expand upon it, make your own version, or do something different from the lessons that you learned from watching that. But those are going to be hours long because it takes some time to build. And I think it's not very useful to rush through that. I could have made some kind of presentation where I just rushed through it, but I don't think that really is as helpful, because I think a lot of you already know how to make web applications, and the documentation for simply adding the Chopin Framework integration is very simple, but actually seeing the process end to end will probably be a lot more helpful to people. So I'm going to have all of that and more over the coming weeks. I'm going to have a lot of tutorials. We're going to have right now you can run it locally with chopd, but we're going to also have a production ready hosting option. And we're also going to have a bridging solution. So all of that's coming soon. So, and with the bridging solution, you'll be able to bridge out of what currently would be considered a sovereign rollup. It's not bridged to any other crypto ecosystem. With the bridging solution, you will be able to transfer tokens in and out of your web app. And that's all that I have for this presentation. Is there any questions?
We have got lots and lots of questions in chat. So we'll start off with the questions tab. If anyone hasn't put their question in the questions tab, it might get lost in the chat. So think about rewriting it in the questions tab so we don't miss it. We'll start from the earliest question, and that was Mohammed asking, does the user have custody of the embedded wallet?
Yes, the user. So what we use is Capsule. You can go, it's usecapsule.com is their website, and we use their pre-generated wallets to power our service. So you can enable the feature where the user can claim the wallet that has been pre-generated, but by default they don't have custody over it, because that would degrade the experience. If you made them opt in and jump through a bunch of hoops to obtain custody before generating the key, that would potentially, that would just basically make the user experience worse. It's possible to set it up so that it works that way, but that's not something that we have gone with. So we recommend, like, when a user is first coming to your app, what you want is you want to have low friction, and you want to get them to actually use your app. And you don't want this to be a blockchain app. You want this to be like a normal Web 2 app. And then you want to basically, what's called like the progressive disclosure of complexity. You want to allow them to then claim that app once it becomes important to them. What's cool about Capsule's system, and that you can go in their docs and look at all their security assumptions. But what's cool about how they do it is that it's an MPC wallet. So we never have your key. You never have your key. Nobody ever has your key. Your key is distributed across multiple parties. So it's not like the fact that we were fully managing your wallet and nobody had custody of your wallet, that does not increase the risk of your key leaking. So it's a secure way to maintain custody until somebody wants to kind of escalate their level of control. And of course, it is possible to integrate other wallets, as I had mentioned earlier, like MetaMask and stuff, where you the whole time would have custody of your key. We wouldn't use Capsule. This is an integration we haven't made yet, but it's 100% possible. It's not a big deal to add. It's just that what we've been doing has been really focused on getting this Web 2 experience polished.
Mohammed actually followed up in the chat saying thank you. And does the custody claim need to be done via Capsule, or does Chopin have built-in functionality for it?
So I haven't released the docs for how to do that, but I will do that. I'm going to make a note of this. It would be through Chopin. Okay,
very nice. Mohammed has also asked earlier on, isn't it going to end up costing a lot if each message is stored on chain, e.g. a chat out with groups and channels where thousands of messages are being sent?
Well, yes. I mean, yes and no. It depends it depends, because, so first of all, you have to realize that all blockchain transactions have to go on chain. So an HTTP request is a transaction. You have to think of it as a transaction. It's not something that's fundamentally different. Actually, it's way more, the way we do it is way more efficient. Like the way that a normal blockchain-based app is basically there's a transaction, like an Ethereum transaction, that's built on the client side and it's wrapped inside of an HTTP request. And then that is sent to the server. And so it's kind of like actually a transaction within a transaction, because an HTTP request is basically a like data that's packaged to cross the boundary from an untrusted to a trusted compute environment. And that's also what a transaction is. So you're kind of doing that twice. This is a very inefficient system. It's better to actually just use HTTP requests, which are what the browser already does, in order to, as the basis for transactions. But all that aside, yes, I mean, at the end of the day, that's how blockchains work. What I will say is, like, that's the whole point of Celestia. The point of Celestia is to bring down the cost of data availability to a very, very low margin above the actual baseline cost that it costs to provide in the first place. So if you go and watch, I did share this older presentation that I had done on the Celestia developers channel with Josh. And I walk through how Celestia will be able to actually get to internet scale. So we would have like potentially like an entire data center, like as powerful as something like Cloudflare or you know, like you name it. And this would actually be able to, like, that's like the level of scale that Celestia would be able to provide, and the economics would actually work. It would, of course, be more expensive than just running in the web 2, but you have to remember, like, let's say you make a web app in the first place. It's probably not breaking the bank for you. Like, if it was more expensive, it wouldn't necessarily be cost prohibitive. Software has very huge margins, and a lot of time people are happily on the free tier. And so yes, it will definitely be more expensive, but it's not going to be so far, you know, there's no reason to think that this is going to be cost prohibitive.
On that, like a similar kind of theme, Kamal has asked, how is it, so they've noted that there's a cost for using Chopin. Is there a free tier available for Hackathon participants, or what do they have to do to be able to use Chopin?
Yeah, so there's several ways of looking at this. First of all, to use ChopD is free because it's a developer tool. So that simulates running in production. It doesn't actually put the data on the blockchain because it's for development purposes. There's no reason to do that. So what I recommend is just building your application with ChopD, and then it'll be ready to go when you actually want to deploy that into production. But there will be a self-host option that's launched alongside our production hosting option. The production hosting option will be paid, and the self-host option will be free. But it'll be very affordable. Let me just say, the paid version will be very affordable, and you will be able to, you'll be able to deploy it and use like serverless stuff to deploy all of this stuff. So it's going to be easy to manage, and you can use your own light node and your own testnet tokens. If you want to put it in production, though, you're going to have to pay. That's just a fundamental reality of how these systems work. So the two ways you could do that would be through our paid option, where we manage that for you, or you could buy your own tokens and mainnet tokens, TIA, and then you would just fund your wallet, and the self-host option would work. You wouldn't have to pay us anything. It would work.
Okay,